So now let's talk about limiting reagent. Now when more than one reactant present with their quantity, the amount of product formed depends on particular reactant which is earlier finished. It is called limiting reagent. So when you have more than one reactant and forming a compound C, and the reactant should be more than one. Okay. So now you the which ends earlier. Let's say B is in less amount as it should be, and A has some amount. So lesser amount it will finish first. So here in that case B is known as limiting reagent. Now let's consider example like if you have like 20 liter of oxygen and you have like 6 milligram of carbon. Now if you try to burn this, if you light this, so how many gram of CO2 will form? How many gram of CO2 will form will depends on this carbon, because if you see the reaction C plus O2 forming CO2, C plus O2 forming CO2. So here you need moles of carbon divided by 1 should be equals to moles of oxygen divided by 2. Moles of oxygen divided by 1. So moles of carbon divided by 1 equals to moles of oxygen divided by 1. So here we know that moles of oxygen require equals to moles of carbon. So 6 moles of carbon, that much oxygen only we require. That is the used oxygen. Remaining is known as excessive reagent. This oxygen is now a excessive reagent. Means when we have one present in limiting amount, now the reaction will go according to carbon. Here the reaction will go according to carbon. So now this carbon is limiting reagent. Now how much amount of CO2 is formed divided by 1 we will calculate by limiting reagent only. Okay, that will be calculated by limiting reagent. Here by NO2 we will get the amount of O2 used. Now this is amount of O2 used, then we will subtract it by original oxygen, then it will be the oxygen left, and the number of moles of CO2 formed will be calculated by limiting reagent only. Okay, so limiting reagent can be identified by calculating given mass of reactant per stoichiometric coefficient. Reactant which have least moles is LR. Reactant with least moles is LR. LR is completely used on completion of reaction. Therefore, mole calculation proceed with respect to limiting reagent. The mole calculation proceed with respect to limiting reagent. Now, let's say if again we take an example, N2 plus 3H2 gives 2NH3. N2 plus 3H2 gives 2NH3. Now we know the like if we have 1 moles of N2, if we have 5 moles of H2, now if we have how many moles of ammonia will form. So we know from this is a balanced. First step we have to check whether it is a balanced chemical equation. When it is balanced chemical equation, then by stoichiometry we know number of moles of N2 divided by 1 equals to number of moles of H2 divided by 3 equals to number of moles of ammonia divided by 2. So now we know that 1 mole of N2 and 3 moles of H2 is present. So we will check moles. What is the value of N2 by 1? N2 by 1 is 1 by 1. What is value of H2 by 3? So number of moles of H2 by 3 is 5 by 3. So now we know that 1 by 1 is 1 and 5 by 3 it is 1.66. So which present in less amount? We know this present is less amount. So here N2 will be the limiting reagent. Okay, the N2 will be the limiting reagent, and we need 1 moles, and here H2 will be the excessive reagent. Now suppose again we take an example like again we have a reaction like A plus B is forming C plus a D. So from stoichiometry we know that number of moles of A divided by A should be equals to number of moles of B divided by B, number of moles of B divided by stoichiometric coefficient B. That will form number of moles of C divided by stoichiometric coefficient C, number of moles of D that we will form by number of moles of D divided by stoichiometric coefficient D. Now let's say we have given amount of A, some moles of B. Now we know which is they should be equal actually, but when they are not equal, then one should be higher, one should be lower. Okay, one value should be higher, one value should be lower. Let's say Na by A is greater than Nb by B. So here Nb will be the limiting, this B will be the limiting reagent, and calculation will be made by this. So let's jump to an example. In a Haber process, 34 gram of N2 is mixed with 10 gram of hydrogen gas to form ammonia. Calculate mass of ammonia produced and mass of reactant remaining. So now we know that the N2, the Haber process, N2 plus 3H2 is forming 2NH3. We have given 34 gram of N2. So what is given? We have given 34 gram of N2 and reacting with 10 gram of H2. Now how many moles we have? Moles we have is 34 by 28 gram. Now here we have 5 moles. Now here we have 34 by 28 moles. Here we have 5 moles. Now that is equals to 1.2 moles. Okay, we have nitrogen 1.2 moles. Now number of moles of ammonia from now we know that according to this is balanced chemical, because this is a balanced chemical equation. So according to stoichiometry, we know number moles of NO2, moles of N2 by 1 should be equals to moles of H2 by 3. That should be equals to moles of ammonia divided by 2. Moles of ammonia divided by 2. So here moles of 10 gram calculate. So here N2, if we put the value 1.2 divided by 1, and what is the value of N2 by H2 by 3? That is 5 by 3, and that comes out to be 1.66. So we know which is less, 1.2 or 1.66. So we know 1.66, 1.2 is less. So here that we will consider as the, here it is limiting reagent. They both should be equal according to stoichiometry. Now we know the nitrogen is less, that is 1.2, and it is 1.6. So it is limiting reagent. The mass of ammonia product and mass of reactant remaining. So now how we will say mass of reactant product? So we know ammonia will form according to nitrogen. So moles of ammonia. Here if we see what is moles of ammonia, moles of ammonia will be moles of ammonia. Here moles of ammonia by 2 should be equals to moles of N2 by 1. So moles of ammonia will be equals to how many moles of N2? Moles of N2 we have 1.2. Now multiply by 2. If we cross multiply this here, so now number of moles of ammonia, that will be equals to 2.4. Now ammonia will be 2.4, and the mass of ammonia, if we see the mass of ammonia, that will be equals to 2.4 into 17, that means 40.8 grams. So ammonia will be 40.8 grams. Now if we see further, now how much and mass of reactant remaining. So and we should also know how many H2 has reactant. So moles of H2, if we calculate about hydrogen, so NH2 by 3 should be equals to NN2 by 1. So we know NN2 is 1.2. So moles of H2 used is 3 into 1.2, that is 3.6 moles. 3.6 moles means 7.2 gram. So mass of H2 reactant is 3.6 multiplied by 2, that means 7.2 gram. And how many gram it has given? 10 grams. So mass of H2 used, that is used is 7.2 gram. So mass of H2 remaining, mass of H2 remaining will be mass of H2 given minus used. So the remaining will be 2, it will be 2.8 gram. So 2.8 gram will be the mass of hydrogen remaining. So here we get mass of hydrogen remaining is 2.8 gram. Now if we see, now that was the moles of, it is 2.8 gram. So that's how we do the calculation when we consider first stoichiometry when it is a balanced chemical equation. Then we know all these terms should be equal. Now in the reactant which is given less, this we consider as a limiting reagent. Now if we consider that limiting reagent, the reaction will be go according to that. In the formation of nitric oxide from NH3, 34 gram of NH3 reacted with 160 gram of O2. Calculate moles of NO produced and also show that mass of remain conserved. So now we know in the formation of nitric oxide, we have 2 NH3 plus 5 by 2 O2. 2 NH3 plus 5 by 2 O2 gives 2NO plus 3H2O. 2NO plus 3H2O. Now in the formation of nitric oxide, for ammonia. So now ammonia, if we have given 34 grams, we have 34 grams of ammonia react with 160 gram of O2. Okay, now we know again. Now what will the moles will be? Here we have 2 moles, 34 divided by 17, that we have 2 moles. And how many moles of oxygen we have? Moles of oxygen 160 divided by 32. So we have 5 moles of oxygen, 2 moles of ammonia and 5 moles of oxygen. Now we know according to stoichiometry, if we talk about the stoichiometry, moles of ammonia divided by 2 equals to moles of oxygen divided by 5 by 2. That should be equals to moles of NO divided by 2. That should be equals to moles of H2O produced divided by 3. These are reacted, these are produced. Now we know what is the value of ammonia, moles of ammonia. It is 2 divided by 2. And we know what is the value of O2. It is 5 into 5 by 2. So that comes out to be 1, that comes out to be 2. So we know ammonia, here ammonia is a limiting reagent. Now from here we got that ammonia, it is a limiting reagent. Ammonia is a limiting reagent. Now when ammonia is a limiting reagent, then the moles of ammonia used is 1. The moles of ammonia used is 1. Now if we want to calculate how many NO used, so we will equate this with that limiting reagent. Okay, answer will be given by limiting reagent. So moles of NO produced. So moles of NO divided by 2 should be equals to moles of ammonia divided by stoichiometric coefficient. So how many moles of NO produced? The moles of NO produced will be, now here we know we have 2 moles of NO, 2 moles. So moles of ammonia produced will be, to cancel 2, it is 1. So N of NO, moles of nitric oxide present will be 2 moles. And so mass of remain conserved. Now we know how many moles of O2 should be used. We know, now we will equate this by limiting reagent. All the calculation we have to made by limiting reagent. So moles of O2 divided by 5 by 2 should be equals to moles of ammonia. Moles of ammonia is 2 divided by 2. Now 2 to 2 will cancel. So moles of N2 used, moles of O2 used will be 5 by 2 moles. Now if 5 by 2 moles is used, so what is the weight of O2 produced? It is 5 by 2 multiplied by 32 and 16. Now 16 or that 8. So 80 gram of O2 will be used. So how many O2 is remaining? O2 remaining is mass of O2 remaining. Mass of O2 remaining will be 160 divided by 80 gram. That is 80 gram of O2 will remain. So now again we got that the only thing we need to remember while calculating the balanced chemical equation moles is that stoichiometric rule. Okay, that stoichiometric rule, that only we need to consider